Hello, I am Professor Rios. In this occasion, we're going to learn about industrial controls. Simple industrial control involves the following. With the push button, we can start a motor, and with the red push button, we can stop the motor. With this single switch, in one position, the motor will be rotated in one direction, and in the other position, the motor is going to be rotating in the other direction. Another added problem is that this motor is going to be DC motor. Therefore, we need a DC power supply. This unit works with AC. Okay? So these relays works with AC. So we're going to have two parts being powered by two different power supplies. One is AC and the other is AC, and they are going to interact to make this whole thing work as expected. How are we going to achieve this? The moment you want to design something like this, what you have to have clear in your mind is how it should work, okay? And this is my interpretation or how it should work. The first thing that we have here is the on-off switch. Maybe you should go around and take a look at this here, because otherwise it's going to be apart. Okay, this is the on-off switch. The on-off switch, I'm going to represent the on-off switch by a simple switch like this. Okay, this is the on-off switch that is in the side of the board. This switch, once you turn this on, is going to be giving us 24 AC, alternating current. Okay, so you turn the switch on, and that switch will power a normally open switch. How do you represent a normally open switch? You see the connections here, you see the connecting bar here is not making contact. Therefore, when I press it, it goes down and makes the connection. That's normally open, okay? Then, this is the switch that is going to start the motor. Then I'm going to have another switch that is going to be a normally closed switch. You represent the normally closed switch like this. Okay, you see these contacts are connected to this connection point. Therefore, without pressing it, it's on. It's normally closed. So when I press it, it opens. This is the one we're going to use to stop the motor. So at the output of the switch, I'm going to have a relay. Okay? Okay? And this relay is going to be connected to neutral. So we have line here and neutral. In this connection point, we're going to have line and neutral. Okay? So this is my neutral, this is my line. This relay will work in the following way. Because right now, when I press here, the relay will be activated for the time that I'm pressing my finger. When I let it go, the relay will not be activated anymore, right? But I'm going to make a connection here so you will see how you can keep a relay engaged after releasing the button, okay? So, these relays have double connections. They have a common, a normally closed, and a normally open, and another side that is exactly the same. A common, normally open, and normally closed. And this is the representation of those contacts. You have a common, you have a normally closed, and a normally open connection. Okay? You have another set also the same as that one. It's like this, normally closed, and normally open. Okay? This whole thing is part of the same unit. And you represent that like this, with dotted lines. Okay? All it means that this, everything that I drew here is basically contained in one of these relays. Okay? Inside here is the coil, and inside here is the two sets of contacts. One is in this side, and the other is in the other side. Now, how do I connect this in such a way that when I press this, the relay stays connected? What I need to do when I press here, here what happens? This relay is activated, and this one is connected with this one, which now is open. I'm going to place this in parallel with the connection. So what is happening now? The moment I press the relay gets excited, this connection closes, so this closes. So even if I release my finger, the current will go through the contact of the relay. Okay? Now, how can I stop the relay? All I have to do is to press this button. It will interrupt the current of the coil, and the relay will stop. All right? So with this contact, we achieve connection and disconnection of the motor. Okay? Now with this motor, we achieve engaging the relay, and with this other set of contact, we achieve connection and disconnection to the motor. So now the motor has a DC power supply. So we're going to represent that by this. We're going to have positive 12 and negative 12. Okay, DC, right? So I'm going to get this DC from the power supply. I'm going to connect this here. And the output of this connection, I'm going to connect it to the circuit that will control the direction of the motor. All right? Now, I turn that on, the relay engages, disconnects, provides the 12 volts of the DC power supply. Okay? When this powers that, it's going to go to a switch that will turn on and off another relay. Okay? So this relay is gonna be like this, okay? And this part of the relay will go to the negative. No, this is wrong. I'm gonna tell you why it's wrong, okay? And I realize, continue recording. I'm going to tell you right now why these circuits were not working yesterday. The circuits were not working yesterday because these relays work with AC, alternating current. And what we did yesterday, we connected that same relay to the DC power supply. So when you connect the DC power supply to a relay that is supposed with alternating current, you achieve the brrrr. It doesn't keep the relay engaged. That's the problem that we're having. Yeah. So how do we do it right? This connection engages this relay, okay? But engages this relay with the original power supply of 12 volts, okay? And in order to do that, I'm going to do the following. I'm going to get the power out of here, and I'm going to connect this to the switch. not to that one, it's like this. Okay? I connect this power to here. This will connect or stop the motor. So this continues like this. Okay? It goes like this, and this one is the actual line that activates the coil of the relay. Do you follow me? Look. You press the button, relay gets activated. This thing connects with this. The power here, 24 volts AC, goes through the contact and now turns on the motor. Okay? When I want to stop the motor, I press here, I close the power for the whole thing, and it stops. So, when this is activated, it gives me power here, that gives me power to turn on and off this relay with AC voltage, okay? Therefore, this part of the power supply needs to be connected to neutral, okay? To the neutral of the original AC. Now, the output of this is going to be the same as that one common, one normally connected, okay? One normally open, one common, one normally connected, one normally open, okay? This is my relay enclosed in the dotted line. All right? And now this relay, what it does is change the direction of the current, the direction of this power supply. Okay? So I'm going to put my motor here. Okay? And each side of the motor is going to be connected to the common. So this is one common, goes connected here. This is one common, is going to be connected to the other side of the motor. So in order for this to be rotated in one direction, this one, let's say, is positive, okay? And this one has to be connected to a negative. So this positive have to be bridged with this one. And this negative have to be bridged with this one. Okay? So what happening? My positive of the power supply goes to the positive, and the negative of the power supply goes to a negative. Okay? So what is the situation? When this power is off, I have the positive here, and here should be the negative. My negative through here is connected to this side. The motor is in one direction. When I activate the switch, it should be the opposite. So when this thing moves this way, now this part of the motor is the negative, and this part of the motor is the positive. Okay? That's how you achieve the changing of direction of the motor. Is that clear?